Using numpy to build an array of all combinations of two arrays. I'm trying to run over the parameter space of a 6-parameter function to study its numerical behavior before trying to do anything complex with it, so I'm searching for an efficient way to do this. My function takes float values given in a 6-dim numpy array as input. What I tried to do initially was this. First, I created a function that takes two arrays and generates an array with all combinations of values from the two arrays. Then, I used reduce to apply that to m copies of the same array. Finally, I evaluate my function like this. This works, but it's way too slow. I know the space of parameters is huge, but this shouldn't be so slow. I have only sampled 106, a million, points in this example, and it took more than 15 seconds just to create the array values. Do you know any more efficient way of doing this with numpy? I can modify the way the function f takes its arguments if it's necessary.
In newer versions of numpy, 1.8.x, numpy.meshgrid provides a much faster implementation. For PV's solution. numpy.meshgrid used to be two-dimensional only, but now it is capable of multidimensional. In this case, three-dimensional. Note that the order of the final resultant is slightly different.
Here's a pure numpy implementation. It's about 5 times faster than using itertools. Python 3. Python 2.
itertools.combinations is in general the fastest way to get combinations from a Python container, if you do in fact want combinations, i.e., arrangements without repetitions and independent of order. That's not what your code appears to be doing, but I can't tell whether that's because your code is buggy or because you're using the wrong terminology. If you want something different than combinations, perhaps other iterators in itertools, product or permutations, might serve you better. For example, it looks like your code is roughly the same as. All of these iterators yield tuples, not lists or numpy arrays, so if your F is picky about getting specifically a numpy array, you'll have to accept the extra overhead of constructing or clearing and refilling one at each step.
You can use np.iteratortools.product A, B.
If you want to anywhere, there's a considerable trading